In this particular problem, we're dealing with the standard 8.F.1, where we're dealing with functions and how they relate to inputs and outputs. In this particular problem, you can see that we have a function represented by the linear equation y equals 5x minus 4, and we're trying to figure out which table of values can be represented by that particular function. Now, in this problem, it may be only one table, it might be two tables, it might be all of them for that matter. So we really do have to check them. So the fastest way of dealing with a problem like this is really just checking one of the x comma y's, or one of the ordered pairs, or one of the input outputs, however you want to look at that. And it really doesn't matter which of the points within that table that you use. I tend to go with the smaller values just simply because we're less likely to make a mistake, even though we do have a calculator here. So I think in the first one, I am going to use the input-output XY value right there. Once again, simply because the values are smaller. So we know that the y value is 4, so we're replacing y with 4, and we are replacing x with negative 2. Remember, 5x means 5 times x, and we're simply trying to see whether that is a true statement or not. And so then we've got 4 equals 5 times negative 2 is negative 10, and clearly negative 10 minus 4 is not positive 4. So we know that one's not going to work, okay? So I'm just going to kind of do the same thing all the way through our table here. So once again, I'll start with y equals 5x minus 4, since that is our function. And I don't know, maybe I'll use the second one again, because those values look like overall they're a bit smaller. And also, if I have a choice between positive values and negative values, I'll choose the ones with positive values. So the x value is 5, so I'm replacing x with 5, and the y value in that ordered pair is 30. So we've got 30 is supposedly equal to 25 minus 4. Clearly, I can see that that's not a true statement, so therefore, that one doesn't work either. Okay, so that means that table is not represented by the function y equals 5x minus 4. I'll start with the third table now. I got y equals 5x minus 4. I'll take the second one again. The y value is 11. The x value is 3. And so we've got 11 is equal to 15 minus 4. Clearly, that is a true statement because 15 minus 4 is 11. So we know that the third table it does represent that linear function y equals 5x minus 4. So I'm going to take off my writing here and go ahead and select that table. And now I'm going to check the last table. So once again, our function is y equals 5x minus 4. Just for the heck of it, I'm going to take the fourth value this time. So there are a set of values. The y value is negative 75. The x value is 20. And so we've got negative 75 supposedly equal to 100 minus 4. Clearly, we can see that that is not equal because 100 minus 4 is 96. So this table is not represented by the function y equals 5x minus 4. So it looks to me like in this one, it is only the third table. So that's how you deal with a problem like this from this particular standard.